Alright, my name is Brandon Gogetap, and today I'm going to talk to you about reactive view models and how they can help you. So the first idea is, or what reactive view model solves, is view state and where to persist it. You can use a SafeState subclass in your view where you serialize and deserialize relevant fields. So you have to override on saving since state, on restoring since state in the view. That works, but it's kind of boilerplatey, and if you ever add a field that needs to be saved, if you have a configuration change and forget to add it in your SafeState subclass, then you're going to have kind of some subtle bugs because that's not something that's obvious or pointed out to you. If you're using dependency injection and have a scope singleton presenter that survives configuration changes, you can store your state there. That's very easy, but it can kind of make your presenter perform more functions than it really should be doing, and that'll definitely clutter it up the more complex views you have. Or you can use something like database, which for some apps is probably the preferred route. So a messaging app, as a new message comes in or as a new message is sent out, putting that in the database and then updating the view from the database is probably the direction you want to go, just because this is normally in a messaging app stuff that's going to be persisted for, it's not like transient data, so it's going to be there. You're going to want it the next time the app loads. So storing in long-term storage makes sense, but this isn't the case for most apps. So if we look at the presenter to view relationship, having to use a new presenter class for each view isn't really an issue. And actually it's probably mostly an advantage because you can have it be as specialized as it needs to be for that case. But dealing with the interactions between them can be kind of bothersome. So again, if you're using a singleton or scope singleton presenter that is going to be around through many iterations of a view's lifecycle, then you're going to have a nullable view as a property or as a field on that presenter. So anytime you want to call into it to update, you'll have to do a null check. You have to remember to detach the presenter in the view when it's being destroyed, and then separating first attach logic from subsequent attaches. So the first time a view attaches to a presenter, you probably want to trigger some load. You may have triggered this before, that's probably the better way, but if you attach presenter, you want to trigger to load the data that the view needs. Now, if you have a configuration change and the presenter has already loaded this data and the view attaches on its next life cycle, you don't want to trigger that same sequence. So maybe you have some sort of branching statement in the attach logic. However you do it, there's probably something you have to do, which again just leads to cluttering the presenter. Oh yeah, and my asterisk, which really should apply to all three bullet points under the main one, is really only an issue if you're using singleton presenters. If you're creating a new presenter on every view lifecycle iteration, then none of these really are an issue. So this is kind of how the relationship looks. Your view calls attach or detach. It passes user input actions to the presenter, and then the presenter does whatever it needs to do with those actions or with the repository and manipulates the data how it needs to and sets that data on the view. But normally for efficiency's sake, this isn't just one call into the view. You are probably setting header text or background color or items or however many ways you need to split it to be efficient. And that's something at each of those stages you are going to have to do a null check on the view. There's that many methods in your presenter now, and there's that many methods that have to be exposed on your view to the presenter. Whether it's behind an interface or not, it's still clutter. So, like I said, it's usually not just one method call into the view to set the view state. And I basically just said all of this. So clutter is the main takeaway of a traditional presenter-view relationship. And then when we get to testing the presenter's view updating logic isn't perfect. Most of the time, I'm sure you're probably assuming the view is not null. So you assume it receives the call, but what if the data comes in when the view's in an in-between state? Above point, only important, or not important, not a big deal if the logic is sound in your presenter. So if a view does become attached and you already have the data loaded, if you have that all sorted out, it's going to work fine. But it still comes down to where do we store the state of all of the data that's supposed to be set on the view? And is it multiple fields in the presenter, or do we have one object that each time the view attaches we disassemble in the presenter and then pass it on to the view? Or do we pass that object to the view and let it disassemble, which is probably the least ideal case, because no matter how simple, you're still moving logic into your view beyond just setting text or something simple like that. So, in my opinion, I think the ideal view lifecycle would be the view would create itself, it would subscribe to something that tells it what to display, it would pass its actions on to another class, and presenter is perfectly fit for this. And methods to update the view should not have to be defined or exposed at all. And so here is my diagram of a view model interaction. And one thing to take away from here is nothing is talking to the view. And I think that's important. So when the view subscribes to the view model, it's using, let's say, a behavior subject or behavior relay. I don't think I'm going to cheat and not count that as two-way, because the view model still doesn't know about the view. I guess you could say its observables do have a subscriber, but the view model can be used on any view that wants what it's providing. So it doesn't care if the view's there or not. The presenter doesn't care if the view's there or not. And the view model can even operate with the repository directly. And I'll show you an example of that. But I think traditionally you probably have the presenter act as a middleman there and then pass that data on to the view model. All right. So, kind of the steps: the view subscribes to the observables in the view model and unsubscribes. So you still have that case that could still, your view model is a scope singleton, so you have to remember to unsubscribe. That can still cause leaks if you don't. The view model can be updated at any time. So, like I said, it doesn't care if the view's there or not. If the presenter loads something from the repository and passes that on to the view model will happily hold on to that until the view decides to subscribe. And again, presenter doesn't have to know about the view, so we have no null checks needed anyway. And then the view doesn't expose or even define any methods that are needed to allow other classes to update it, because other classes don't know it exists and they don't need to update it. And then view model can be unit tested. This is, I think, slightly better than the way you would test your view updating logic in a presenter. We can look at an example of that, but nice thing about it is it's a very specific unit test, so it's nice to have this kind of logic split out into its own class. And then that includes any manipulation of the data into what the view needs. We would ideally encapsulate in the view model. So we wouldn't pass the view some big object that has 10 fields and the view would decide what to do with that. We should just tell the view, or the view should just say, I need text for this, give me a text observable. And so there's not really a strict implementation. You can go, obviously, whichever works best for you. Like I said, the view model could talk directly to the repository, and the presenter would never have to even know about the view model. Depending on view complexity, you can either expose observables for each widget, or, like I said, you could expose an object and have the view disassemble that, but I don't think that's ideal. And in very simple cases, I think it wouldn't even be a bad idea to have the presenter exposing that observable if there's just, let's say, a list of items that your view needs. Maybe having a dedicated view model class in that case is a little overkill. But again, it's really whatever works for you. The idea is the same no matter how you do it. So the view model itself is a scope singleton provided by something like Dagger, ideally. It exposes behavior subjects or behavior relays as observables, and the important thing behind a behavior subject versus like a published subject is the behavior subjects remember the last emitted value, so they will always have the most recent view state. And then, depending on how you have your view model being updated, you could have the observables be behind an interface so the view only sees what it needs. Otherwise, you would have all the other methods to update the view model exposed to the view, which, depending on your preference, is something you might not like. So here's a very simple one. Ironically, the case I said that a presenter would probably fit, but it's good to start here. So this view model is injecting a repository, and it is retrieving the items. So in this case, there's no need to update the view model from the outside. And we have a behavior relay that emits a list of list items. And we just expose an observable of that list. And it's behind an interface. And in this case, again, little overkill because there is only one method on this, so it's all the view would see anyway. But yeah, this method here, to make this work without the view model needing outside help to be updated, this ideally would be a hot observable. So if you use something like Realm or SQLite, you can query database and get automatic reemissions anytime that table is modified. So this would be a fully functioning view model that would stay up to date, assuming you have the correct database implementation. If you did want to have an outside class update the view model, you could have a method like this that would expose the relay, and here the presenter could get the relay and then emit the list items directly. Or you can just pass in the list items and have the view model deal with all the reactive parts. Really, again, just whatever works best for you. And on the view side, and this is just a snippet of I'm using Conductor in the example app. So I have a view bound method where I will subscribe to my view model, and I'll add it to a composite disposable. And what that allows me to do is however many observables I subscribe to, I can unsubscribe with one line of code at the bottom when the view is destroyed. And this set data method is private. It's really just there to kind of separate the logic. I could easily move those 2 lines of code into a lambda in the subscribe method. But I think this is nice to kind of set it up. But that method is obviously not exposed to any other classes. So here's a slightly more complicated one. Yes. So.
Can you go back to the last slide? Oh, yeah, you were on the right one, my bad. Okay. How does this work if, like, you want to show an empty view? So, like, say that repository is an asynchronous network call, and you want to show a loading spinner here until the first time the data comes back.
Sure. For that, I'd probably just have another observable on the view model that is view state, or however you're defining your view modes. You could have that emit, and you can. They're all grayed out. You can supply these relays with a default value. So if you had a view state relay, you can do create with defaults, loading, or what have you. So that would be, if the view attached before your view state was updated, that would be the view state it would get. So yeah, that probably would never have something this simple because, like you pointed out, that's probably good to give a user some indication that it's loading. But I think that can be pretty easily handled by this pattern. Here, I think I have these. All right. Yes. So here's a slightly more complicated one. It's really the same thing, just times 4. But we have a title relay, message relay, color to set the background color, and then the ID of our item. So here we're just initializing our relays in the view model constructor. We're again injecting a repository, so we don't need any outside help to keep us up to date. And we're subscribing to get the item, and then we are disassembling that item into its pieces and updating our relays ourselves in the view model here. And now the view sees these 4 methods. It subscribes, it sets the appropriate views up like so. And anytime, again, if you are using something like SQLite and you update the name of the item that you're subscribed to, that will be re-emitted to your view model or to the repository subscription, which will then trigger another disassembling of that item into the respective relays and the views sitting here subscribed, so it will get updated and update what's needed. And you could do something like have filters on these or distinct until changed, and actually you could probably have that on the view model side to hide it from the view, where it wouldn't re-emit title text if it hasn't changed, just to kind of squeeze out as much efficiency as you want. So again, there's many ways to go about it. Just do whatever works best for you. The main takeaways are all view state is kept in these behavior subjects or behavior relays, and all interactions are one way. No other class cares about the other, and in some cases, like with the view model dealing with the repository directly, no other class cares that any other class exists, and they can still just do their functions as they're created. Here's an example test method. So we're testing our simple one here. We create a test observer, which allows us to validate that certain items were omitted, and we subscribe to our repository method there with our test observer, and then we will emit into the relay. And sorry, these fields are defined in the whole test class. I can pull it up, but they're also in the repo on GitHub. We are manually emitting to the relay a couple lists, and these are the go-to lists, or get list with count is just a helper method in the test class that generates auto value. These are auto value types, so we're always gonna, if you call to, it's gonna be the same list as when you call it next. And we can validate that our observer received those two items in order. See, when I don't have it extended, I can't see the next slide, and I don't realize that I have these all highlighted in sections. And here's our more complicated one, which again is basically the same thing, just times 4. We initialize everything here. We subscribe to our view model with our test observers for each property. And then first and second are just two static list item classes, or instantiations that I have defined in the test class, and I'm emitting them. They have slightly different titles, slightly different message. And down here, I can just verify that each observer received the property of the first, followed by the property of the second. And this gives me enough confidence that my view model, my view state is set up correctly in the view model. And if all your view is doing is taking these primitives and assigning them to the widgets like text view or setting background color, you could probably go as far as to not even have UI tests for simple cases like this. And I do have the project hosted on GitHub. I also do have it on this computer if any of that wasn't complete enough. Does anybody have any questions? Do you prefer, it looks like you prefer like very primitive subjects, so like just string. Is there a reason you prefer that over like, say, an auto value type that holds all 4 of those values? So that, the reason I think, and I do have one view that has, in a project at home that has like 14 different things, and that subscribing is kind of a big block. But if you give a view an object and it has to assign specific properties to the widgets, I think that's maybe just a little bit of logic that you don't need to expose to the view. Honestly, it's probably not a big deal, and it really comes down to how you prefer. And after I had that class where I'm subscribing to 14 different observables, I was definitely thinking that I might go that way in the future. But at the same time, most of these subscriptions are one line, and if each of those subscriptions is doing something to a view, that's a line you're going to have in your view class anyway at some point. So I don't think it's more verbose, and maybe it's not less ideal. I just think it is, because that's logic you can keep out of the view. And that view model, again, if you are it is not coupled at all, so you can use that on any other view that would need. And maybe you could even have multiple view models feed a complex view. If you had this view model define an item view in one place and you have a complex view that needs that item view in something else, you could probably reuse view models to kind of compose that. I don't know. That's kind of the way I've gone, but I don't think it's really whatever works for you. Mm-hmm. Oh, like operators on when you're subscribing, not in the view model. Um, sure. Oh, yeah. Yeah, and again, at home, I think I did originally have a couple filters or a distinct until change in the view when I could have those, or I could have at least the distinct until changed in the view model. That's probably just something you have to work out with your team and kind of decide on a pattern you want to go. But yeah, it's the full RX Java, so you can go crazy with it if you wanted. Anything else? All right, thank you.